We already have some idea about circular motion. It is a type of motion in which the distance of the body remains constant from a fixed plane. It is further classified as uniform and non-uniform circular motion. Some examples of circular motion are a ball tied to a string and swung in a circle, a car taking a curve on a track, etc. Here we will be discuss about a special type of motion known as vertical circular motion. This kind of motion have two types. Number one, controlled vertical circular motion. In this type, speed is kept constant or is not totally controlled by gravity. For example, giant wheel or roller coaster. For circulating this body, we have to supply energy throughout the motion. Another type is gravity controlled vertical circular motion. Here, motion is controlled only by gravity. We initially supply energy mostly at lowest point. Further, entire kinetics is governed by gravitational force. Means we have to provide energy at lowest point of body only once. After that, the gravitational force takes control on its motion. During motion, interconversion of kinetic energy and potential energy. That means after reaching highest point, kinetic energy gets 0 and at lower point it will be maximum. And for potential energy, at highest point potential energy will be maximum and at lower point potential energy is 0. For example, mass tied to a string, spear of death and vehicle on top of convex overbridge or swinging bucket. You can see these in figure. Under the vertical circular motion, we will briefly study dynamics of mass tied to a string and further discuss spear of death and vehicle on top of convex overbridge. Number 1. Point mass undergoing vertical circular motion. This has two cases. First, where a mass is tied to a string, and second, where mass is tied to a rod. Case number 1, mass tied to string. The bob is considered to be point mass and the string is massless, inextensible and flexible. It is whirled along a vertical circle. So, bob performs vertical circular motion and string rotates in vertical plane. Here, only the bob is performing vertical circular motion. So, we discuss force acting on bob only. So, here we are. The number one force is weight, which is vertically downward. You can see this in this figure. This is a weight. Weight is equal to mg and it is vertically downward. Number 2, force due to tension along the string, always directed towards the center. We can see that this is T1 and T2. These are tension and they are directed towards the center. Because magnitude of T is changing. We consider 4 different points A, B, C, D. In this figure, A, B, C and D on this vertical circle, and then analyze each individually. Further, we have considered 2 extra points diagonally opposite whose tension is denoted by T1 and T2. T1 and T2 are considered to study tension in string at any random point on vertical circle. Because the motion is no uniform or non-uniform, the resultant force due to weight and tension will not always directed in the same direction. So we have to study this using 4 points on the vertical circle. Number 1, which is uppermost position. Number 2, which is lowermost position. And number 3, which is point C and D, that is horizontal string. Now we have to write equation for each position. Therefore, for A, it is mg plus Ta is equal to centripetal force. We know the formula of centripetal force. After putting this formula, we get mg plus Ta is equal to mva square upon r. For B, Tb minus mg is equal to centripetal force. Tb minus mg is equal to mvb square upon r. Here we can see that here we add weight and tension, and here we subtract weight from tension, because at the point A, the direction of tension and direction of weight is same. Therefore, by vector rule, we add these two entities. Here at point B, the direction of these two vectors are opposite. Therefore, by vector rule, we subtract it from tension. So, it is Tb minus mg is equal to mvb square upon r. For point C and D, here Tc is equal to Td is equal to centripetal force, because here mg only helps in changing direction. The uppermost position, Va is the speed of particle at A. Here look at this. R is equal to radius of circle is equal to length of string, resultant of mg, and Ta provides centripetal force. Therefore, mg plus Ta is equal to mva square upon r. Now for minimum possible speed at this point, tension T is in the string should be 0. Therefore, T0 is equal to TA is equal to 0, equation number 1, that is mg is equal to mv square upon r, that is g is equal to v square upon r, and by taking square root we can write this VA minimum is equal to under root of RG. For lowermost position or point B, resultant of mg and TB provides centripetal force. Therefore, TB minus mg is equal to mvb square upon r. Vb is the speed of particle B. Now, while coming down from A uppermost point to B lowermost point, displacement is equal to twice r. If A is here and which is uppermost point and B is here which is lowermost point, then displacement of this is twice r, because r is the radius of this circle, and we can write down this as the displacement of between these 2 points are twice r, which is diameter. Also, motion is governed by gravity only. Therefore, the corresponding decrease in potential energy gets converted into kinetic energy. Therefore, mg twice r is equal to 1/2 mvb square minus half mva square. Therefore, Vb square minus Va square is equal to 4 Rg. But we know Va is equal to under root of Rg. Therefore, Vb square minus Rg is equal to 4 Rg. That is, Vb minimum is equal to under root of 5 Rg. It is equation number 3. To find equation for tension in string, we consider Tb minus mg is equal to Vb square upon r. On subtracting mg plus Ta from Tb minus mg, we get Tb minus mg minus Ta is equal to m under root of Vb square minus Va square upon r. Therefore, Tb minus Ta minus 2mg is equal to m 4rg upon r is equal to 4mg. Here, Tb minus Ta is equal to twice mg plus 4mg. Then it is 6mg, equation number 4. Going from position A to C, change in potential energy is equal to delta Ke, that is mgr is equal to half mvc square minus half mva square. Gr is equal to half Vc square minus Va square. Here, if we take m common from this term and m from this term, these gets cancelled. Then we can write this as twice Gr is equal to Vc square minus VA square, equation number 1. If we consider Tc minus Ta, that is Tc is equal to mVc square upon R and Ta is equal to Va square upon R minus mg. Therefore, Tc minus Ta is equal to mVc square upon R minus mVa square upon R plus mg is equal to m upon R under root of Vc square minus Va square plus mg is equal to m upon R twice gr plus mg. Here is equal to twice mg plus mg, which is Tc minus Ta is equal to thrice mg, because from equation number 1 we can write this as twice gr, and after getting cancelled, this r and this r get cancelled, then it is twice mg plus mg, then Tc minus Ta is equal to thrice mg. Equation number 2. From equation 1 we can write down this as, which I explained above. Arbitrary position on vertical circle. In this, as both weight and tension are neither along same line or perpendicular, so we resolve them. The tangential component of weight, it is mg sin theta, is used in changing speed. While going up, mg sin theta decreases, and while going down, mg sin theta increases. Look at this from figure. In case 2, mass tied to a rod. By far, we discuss motion of mass tied to a string. Today we will discuss about the mass tied to a rod. So instead of string, we have a rod here. Now, in case of string, there needs to be presence of some tension acting towards center to keep the point mass in motion. But since the motion is rigid, we don't need any such tension to maintain point mass in motion. For position A, PA is equal to 0. Also practically, VA is equal to 0, because here velocity is minimum at uppermost position. This gives us the tension and velocity at A. For position B, we consider similar method, that is change in potential energy in going from A to B equals the difference in their kinetic energy. Therefore, we have change in potential energy is equal to delta Ke, that is mg twice r is equal to m Vb square minus Va square upon 2. But Va is equal to 0, therefore mg twice r is equal to m Vb square upon 2. Cancelling out m from both sides, then we get 2gr is equal to vb square upon 2. That is, v square b is equal to 4gr. That is, vb is equal to under root of 4gr after by taking square root. Then for position C, following the same method, we get mg into r is equal to mvc square minus va square upon 2. But va is equal to 0, therefore mgr is equal to mvc square upon 2. That is, vc is equal to under root of twice gr. Also, if we take tb minus ta is equal to t lowermost minus t uppermost is equal to 6 mg. Look at this figure. Tb is equal to 6 mg plus Ta minus T uppermost. T uppermost is mg. Here T uppermost is Ta and its weight is mg. So the direction is different. Then Ta gets cancelled and we have left 6 mg. Sphere of death, or we can say this as globe of death. The globe of death is circus and carnival stunt, where stunt riders ride motorcycle inside a mesh sphere wall. It is similar to the wall of death. But in this, act riders can loop vertically as well as horizontally. The physics of the trick are centered around the manipulation of centripetal force. This is the force that acts on an object as it is moves around in a circular path. All forces have a direction in which they push, and centripetal force is directed towards the center of the circular path. So you can see the real life example, such a bridge. We intend to study the force acting on the vehicle when it is at the top. It only has part of vertical motion. Then let us see how many forces are involved here. Number 1, weight, which is acting vertically downward, and number 2, normal reaction vertically upward. The resultant of these two forces must provide centripetal force. Centripetal force acts vertically downward when vehicle is at uppermost position. Therefore, we have mg minus n is equal to mv square upon r. Then weight should be greater than n to keep the vehicle en route. If the weight is lighter than this n, then vehicle will be thrown away from this curved road. we have mg minus n is equal to mv square upon r. As v increases, n decreases, which may cause the vehicle go tangential. That's why we need speed limit here on the curved road. Normal reaction happens only when two bodies are in contact. Thus, for safe travel, maximum speed limit will be at n is equal to 0. That is, mg is equal to mv square upon r. That is, v square is equal to rg. Then, after taking square root, we get v max is equal to under root of gr. This gives the upper limit for speed of vehicle when on bridge. Another example is roller coaster, where we experience the normal reaction n, which keep us stuck to our seats. It is similar dynamics just like the car. Thank you.